Hey guys, today we're looking at square roots and cube roots and how we simplify them. Remember that you can hit pause at any time if I'm going too quickly to catch up and make sure that you understand everything that's going on. All right, looking at our definition of a square root, if we have a square and the area is s squared, then s is the square root of a. So multiplied s times s equals the area of that square. For every positive number has two square roots, one positive, one negative. So for example, the square root of 9 is 3 because 3 times 3 is 9. Or it could also be negative 3 because negative 3 times negative 3 is also positive 9. Then looking at a variable, so if we have the square root of x, that's the same thing as square root of x, or it's the negative square root of x. And be mindful of where negatives are, because on this next example, the square root of 4, but we have the negative in front. That means that we have the square root of 4, which is 2, and then the only answer is that that negative applies to the front of that, so it's negative 2. So we use this symbol, or radical symbol, to indicate that we're looking for a square root of a number. And just remind yourself that it acts as a grouping symbol in order of operations. So for these two examples I have here, this one is equal to the square root of 25, which equals 5. But the second one, the square root of 16, is 4. And that 9, see how it's not under that radical sign, so this one is actually equal to 13. So those are two very different answers. The next type of number I want you to know about are perfect squares. Perfect squares are a number that are made by squaring a whole number. So for example, we have all of these in this yellow box are perfect squares. So 64 is a perfect square. So when we take the square root of that perfect square, it is a whole number. One example of not a perfect square, that would be 5, because the square root of 5, we do not get a whole number. So let's look at the square of the square root property. Here's the definition right here. We have the square root of x times the square root of x equals the square root of x squared equals x. And if we look at some examples here, the square root of 3 times the square root of 3 is the same thing as the square root of 3 squared, which equals the square root of 9, which then is 3. For our next example here, 4 times the square root of 10 times 3 times the square root of 10. This we can make into 4 times square root of 10 times 3 times square root of 10. And we can organize numbers a little bit differently because it's all multiplication. So square root of 10 times square root of 10, well, that's going to be 10. And we have 10 times 4 times 3, which equals 120. Product of square roots property, here's your definition right there. Square root of a times the square root of b equals the square root of ab. So for our first example we have here, it's the square root of 5 times the square root of 6, which is equivalent to the square root of 5 times 6, which equals the square root of 30. Next property is the quotient of square roots property. Here's our definition. Square root of a over the square root of b equals the square root of the quantity a divided by b. And so for our first example here, we can take this and put it all under the square root, 45 over 5. And then we know that this all, 45 divided by 5, is 9. And so this one ends up to be 3. For this next example, the square root of 80 over the square root of 40, well, this we can change to be just 80 divided by 40, and that is the square root of 2. We can also break square roots down. So if we're looking at the square root of 40, we can think about which perfect squares are factors of our number. So I think about what are factors of 40, and are any of those perfect squares. So I know that 40 is the same thing as 4 times 10. And I know that 4 is a perfect square because 2 times 2 is 4. So I can have 2 and then leave my square root of 10. So 2 square root of 10 is the same thing as the square root of 40. All right, let's try a few out. This first one, I'm going to think about what are some perfect squares that are factors of 48. And so when I look at this, I'm going to write down that 16 times 3, because I know that 16 is a perfect square, and 16 times 3 is 48. And so I have this, and then I'm going to take that and I'll take out any squares there. So 16, square root of 16 is 4. The square root of x squared is x. The square root of y squared is y. And then we have the square root of 3. All right, hit pause. Try the next two without me to see if you get the same answer. All right, for this next one, I factored out and I figured out that 49 times 2 is 98 and 49 is a perfect square. So that I can do the square root of 49 is 7. And then I also know that I can do the square root of those two variables, the x squared and the z squared. So I can take x and z, and then what I have left over is the square root of 2y. For the next one, I have that one started. The square root of 6 times 4 times x squared over the square root of 6 times x squared. And I know that the square 4 is a perfect square, and so that will change to 2, and then x squared, I can do the square root of that, is x square root of 6, and this is going to be over x square root of 6. And if I look at these become 1, because x over x, square root of 6 over square root of 6, and so my result is 2. All right, for fraction exponents, x to the 1/2 times x to the 1/2, well, that's the same thing as x to the 1/2 plus 1/2, and that would be x to the first power, which is equal to x. And so we know that x to the 1/2 times x to the 1/2 is x, then by definition, x to the 1/2, well, that has to be the square root of x. So using what we know about fractional exponents, 100 to the power of 1/2 is the same thing as the square root of 100, which equals 10. So 16 to the power of 1/2 is the square root of 16, which is equivalent to 4. And finally, 5 to the half power, the power of 1/2, is the same thing as the square root of 5. And finally, let's look at cubes and cube roots. Cubes are the third power of a number, so we write it like this, x to the third power, or x cubed. And a cubed root is a number whose cube is the given number. So for example, we have this example right here. The cube root of 216 is 6, because 6 times 6 times 6 is 216. And then we have the cube of the cubed root property. This is really similar to our square of the square root property, where we have the cube root of x times the cube root of x times the cube root of x equals the cube root of x cubed, which equals x. So, some examples of trying out some cubed roots here. The cubed root of 64 is 4, because 4 times 4 is 16, times 4 is 64. The cubed root of 8, that would be 2. And then this last one, we have the cube root of 45 times the cube root of 45 times the cube root of 45. Well, that just equals 45. Finally, I have to leave you with a little dorkiness. Here is another example of a cubed root. Ha ha.